So I've got a whole pizza here, and let's say that I were to cut it into two equal pieces. So let me cut it right over here into two equal pieces. And let's say that I ate one of those two equal pieces. So let's say I ate all of this right over here. What fraction of the pizza have I eaten? Well, I took the whole and I divided it into two equal pieces, and then I ate one of those pieces. And then I ate one of those pieces. So I ate 1/2 of the pizza. Now let's imagine that instead of cutting that pizza into only two equal pieces, let's imagine instead that I decide to cut it into 4 equal pieces. So let's draw that. So 4 equal pieces. So I could cut it once this way, and then I could cut it once this way. And so here I have 4 equal pieces. 4 equal pieces. But let's say that I want to eat the same amount of pizza. How many of these 4 equal pieces would I have to eat? I encourage you to pause the video and think about that. Well, I would eat this piece. You could imagine me eating this piece and this piece right over here. I've eaten the same amount of the pizza. Each of these pieces, you could imagine, got cut into 2 pieces when I cut the whole pizza this way. And so now I have to eat 2 slices of the 4 as opposed to 1 slice of the 2. So I just ate 2 out of the 4 slices. So even though I'm using different numbers here. Here I'm using a 1/2, and here, or 1 in the numerator, a 2 in the denominator. Here I'm using a 2 in the numerator and a 4 in the denominator. These two fractions represent the same quantity. I ate the same amount of pizza. If I eat 2/4 of a pizza, if I eat 2 out of 4 equal pieces, that's the same fraction of the pizza as if I eat 1 out of 2 equal pieces. So we would say that these two things are equivalent fractions. Now let's do another one like this. Instead of just dividing it into 4 equal pieces, let's divide it into 8 equal pieces. 8 equal pieces. So now we could cut once like this. So now we have 2 equal pieces. Cut once like this. Now we have 4 equal pieces. And then divide each of those 4 pieces into 2 pieces. So we'll cut those in. So here we have, so let's see. I want to make them equal pieces. Those don't look as equal as I would like. So that looks more equal. And then that looks reasonably equal. So now how many equal pieces do I have? I have 8 equal pieces. I have 8 equal pieces. But let's say I wanted to eat the same fraction of the pizza. So I could eat all of these pieces right over here. Well, how many of those 8 equal pieces have I eaten? Well, I've eaten 1, 2, 3, 4 of those 8 equal pieces. And so once again, this fraction, 4 of 8, or 4/8, is equivalent to 2/4, which is equivalent to 1/2. And you might see a little bit of a pattern here. Going from this scenario to this scenario, I got twice as many equal slices. Because I had twice as many equal slices, I needed to eat 2 times the number of slices. So I multiplied the denominator by 2, and I multiplied the numerator by 2. If I multiply the numerator and the denominator by the same number, then I'm not changing what that fraction represents. And you see that over here. Going from 4 slices to 8 slices, I turned every slice into 2 more slices. So I had twice as many slices. And then if I want to eat the same amount, I have to eat twice as many pieces. So all of these, 1/2, 2/4, 4/8, and I could keep going. I could do 8/16, I could do 16/32. All of these would be equivalent fractions. Let's think about what fraction of this grid is actually shaded in pink. So the first thing we want to think about is how many equal sections do we have here? Well, this is a 1, 2, 3, 4, 5 by 1, 2, 3 grid. So there's 15 sections here. You could also count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 equal sections here. There are 15 equal sections here. And how many of those equal sections are actually shaded in this kind of pinkish color? Well, we have 1, 2, 3, 4, 5, 6. So it's 6/15 is shaded in. But I want to simplify this more. I have a feeling that there's some equivalent fractions that represent the exact same thing as 6/15. And to get a sense of that, let me redraw this a little bit, where I still shade in 6 of these rectangles, but I'll shade them in a little bit in one chunk. So let me throw in another grid right over here, and let me attempt to shade in the rectangles as fast as possible. So that is one rectangle. I can make my thing even bigger. All right, one rectangle, two rectangles, three rectangles, halfway there, four rectangles, five rectangles, shaded in, and now six rectangles shaded in. So this right over here, what I just did, this is still 6 rectangles of 15 of the 15 rectangles are shaded in. So this is still 6/15. These are representing the same thing. But how can I simplify this even more? Well, when you look at it numerically, you see that both 6 and 15 are divisible by 3. In fact, their greatest common factor is 3. So what happens if we divide the numerator and the denominator by 3? If we do the same thing to the numerator and the denominator, we're not going to be changing the value of the fraction. So let's divide the numerator by 3 and divide the denominator by 3. And what do we get? We get 2 over 5. Now, how does this make sense? How does this make sense in the context of this diagram right here? Well, here we start off with 6 shaded in. You divide by 3, you have 2 shaded in. So what you're essentially saying, hey, let's group these into sections of 3. So let's say that this right over here is one section of 3. This is one section of 3 right over here. So that's one section of 3. And then this is another section of 3 right over here. And so you have two sections of 3. And actually, let me color it in a little bit better. So you have 2 sections of 3. And if you were to combine them, it looks just like this. Notice this is covering the exact same area as your 6 smaller ones did. And then how many equal sections of this size do you have on this entire thing? Well, you have 5 equal sections. And let me go to, because this is one section of 3 right over here. This is another section of 3. And then this is another section. This is another section of 3. So notice you're covering the exact same area of the original thing. You're covering 2 out of the 5 equal sections. So 2/5 and 6/15 are equivalent fractions. So if you want to say what fraction of this is covered in the simplest form, you would say 2/5. So this hexagon right over here, the whole thing is filled in with this pink color. So we'll say that this represents one whole. The whole thing is filled in. Now what I want you to think about is which of these other hexagons have 2/3 filled in. So our goal is to identify the hexagons that are 2/3 filled in. So pause the video now. So I assume you have given a go at it. You have tried to determine which of these are 2/3 filled in. Now let's work on this together. So when you're thinking in terms of thirds, and here we're thinking in terms of 2/3, literally 2/3, what we think about is dividing things into 3 equal sections. So let me see if I can draw a hexagon fairly well. So let me draw the hexagon. And I'm going to try to split it up into 3 equal sections. Whoops. I'm going to try to split it up into 3 equal sections. So this is the center of the hexagon right over here. And so maybe that's one of the equal sections. And then if I do one more line, I've split it up into 3 equal sections. 1, 2, 3. And it's actually kind of neat the way that it's drawn. It looks like a 3-dimensional cube, but that was not my intent. My intent was to draw a hexagon. So let me just, so each of these is a third. Actually, I could write this. That's 1/3. That's 1/3. And this is 1/3. But what we care about is 2/3. So 2 of these 1/3. And so let me clean this up a little bit. So I would fill in 1 of the 1/3, and then 2 of the 1/3, And this right over here, this hexagon that I've just drawn, now has 2/3 of it filled in. Now I know what you're thinking. All right, Sal, that would have been pretty straightforward if these were divided into thirds, but these are not divided into thirds. Each of these are divided into 1, 2, 3, 4, 5, 6 equal pieces. This is divided into sixths. How do we figure out how many of the sixths should be filled in order to have the same thing as 2/3? Well, I would tell you, don't worry too much. All we have to do is we can redraw this, or we can do a little bit of work here to split this into, instead of 3 equal sections, we can split into 6 equal sections. Well, how would we do that? Well, we take each of those 3 equal sections and then split them into 2 equal sections. So this one right over here, I could split this into 2 equal sections. This one right over here, I could split into 2 equal sections. This one right over here, I can split into 2 equal sections. So I had 3 equal sections before. Now each of them have been split into 2, so now I have 6 equal sections. So now, the way I've drawn it, I'm dealing with sixths. And how many sixths represent the same fraction as the 2/3 did? Well, I still have my shaded area. I have 1, 2, 3, 4 sixths. So 4 sixths is the same thing as 2/3. Or another way to think about it, any of these that have 4 out of the 6 equal sections filled in, that means that 2/3 of the sections are filled in. Or I could say that 2/3 of the hexagon is filled in. So let's just look at these. So this one, we have 1. Well, let me do it in a color that has a little more contrast. So we have 1, 2, 3, 4 out of the 6 is filled in. 4 sixths are filled in. That's the same thing as 2/3. So this one represents 2/3. This one only has 2 of the 6 filled in, so it's not 4 sixths, which has to be 2/3. This is 2 sixths. We want 2/3. This one is 1, 2, 3, 4. 4 of the 6 are filled in, so this is 2/3. So I will put a square around that one. And this one has 1, 2, 3, 4 of the 6 filled in. So this is 4 sixths, which we've already figured out is the same thing as 2/3. And we're done. What I want to do in this video is really digest the idea that if we have some fraction, as long as we multiply the numerator and the denominator of the fraction by the same number, that we're going to have an equivalent fraction. So let's think about that. Let's say we multiply the denominator here by 2. So let's say we multiply the denominator here by 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, so here our denominator will be 12. If our numerator here is 4, well, we've got to multiply by 2 again. Multiply our numerator by 2 to get 8. So I'm claiming that 8/12 is the same fraction as 4 sixths. And to visualize that, let me redraw this whole. But instead of having 6 equal sections, we now have 12 equal sections. So each of the 6 we can turn into 2. That's essentially what multiplying by 2 does. We now have twice as many equal sections. Now that we have twice as many equal sections, literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many of them are actually shaded in yellow? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. 8/12. And there's no magic here. If we have twice as many sections, we're going to have to shade in twice as many of them in order to have the same fraction of the whole. And it goes the other way too. This isn't just true with multiplication. It's also true that if we divide the numerator and the denominator by the same quantity, that we are going to have an equivalent fraction. So that's another way of saying, well, what happens if I were to divide by 2? So if I were to divide by 2, so let me divide by 2. I'm going to have half the number of equal sections, or I will only have 3 equal sections. And I'm claiming if I do the same thing in the numerator, that this is going to represent the same fraction. So 4 divided by 2 is 2. So I'm claiming that 2/3 is the same fraction as 4 sixths, as the same fraction as 8/12. Well, let's visualize that. So here, this is 6 equal sections, but now we're going to have only 3 equal sections. So we can merge some of these equal sections. So we can merge these two right over here, and we can merge these two right over here, and then we can merge these two right over here. So our whole is it's still the same whole, but now we only have 3 equal sections, and 2 of them are actually shaded in. So these are all equivalent fractions. So the big takeaway here is start with a fraction. If you multiply the numerator and the denominator by the same quantity, you're going to have an equivalent fraction. If you divide the numerator and the denominator by the same quantity, you are also going to have an equivalent fraction. So with that in our brains, let's tackle a little bit of an equivalent fractions problem. Let's think about if someone says, okay, I have 5 over 25, and I want to write that as some value. Let's call that value t. Let's call that t over 100. What would t be? Well, we can see in the denominator, to go from 25 to 100, you had to multiply by 4. So if you want an equivalent fraction, you have to multiply the numerator by 4 as well. So t will need to be equal to 20. So t is equal to 20. 5 over 25ths is the same thing as 20 over 100. But what if someone says, well, 5 over 25 is equivalent to blank, let's say question mark, over 5. Well, now what would you do? Actually, let's do it the other way. Is equal to 1 over question mark. Well, you could say, look, to go get our numerator from 5 to 1, we have to divide by 5. We have to divide by 5 to go from 5 to 1. And so similarly, we have to divide the denominator by 5. So if you divide the denominator by 5, 25 divided by 5 is going to get you 5. Going to get you 5. So these are all equivalent fractions. 1/5 is equivalent to 5/25, which is equal to 20 100ths.